What are the physics applications of the quadratic formula? Imagine you're throwing a ball into the air or watching a rocket launch. Ever wonder how scientists predict where and when it will land? The quadratic formula helps answer those questions. It is a key tool in physics for solving problems involving quadratic equations. These equations often pop up when describing motion under constant acceleration, like gravity. For example, when an object is dropped or thrown upwards, its height over time follows a quadratic equation. The formula looks like this: the negative of twice the acceleration due to gravity, multiplied by the square of time, plus the initial velocity times time, plus the initial height. Using the quadratic formula, you can find the exact moments when the object reaches a certain height, such as when it hits the ground. This helps calculate how long the object is in the air, or its maximum height. The quadratic formula also helps determine the highest point a projectile reaches and how far it travels before landing. Since the path of a projectile is a parabola, solving the quadratic equation gives the time at which the projectile reaches its peak and when it lands. This is useful in sports, engineering, and safety planning. Beyond motion, quadratic equations appear in other physics areas. For instance, the shape of cables in suspension bridges forms a parabola, which can be described with quadratic equations. Parabolic mirrors and satellite dishes use these equations to focus light or signals. In work and energy calculations, quadratic relationships help relate force, displacement, and energy. When two quantities depend on the same variable and multiply together, the resulting equation is often quadratic. For example, calculating how long it takes to machines working at different rates to finish a task involves quadratic equations. Solving these with the quadratic formula gives precise answers. In short, the quadratic formula is a powerful tool in physics. It helps solve equations that describe motion, shapes, and relationships between variables. It makes finding exact times, heights, distances, and other physical quantities straightforward. This way, complex motion problems become easier to understand and solve.